Okay, in this assignment, we're going to continue looking at different types of interest, but what's going to be different about this assignment compared to the last one is we're not always going to be solving for the final amount. So what I mean by that is if we take the simple interest equation, for instance, last time I was giving you P, APR, and the amount of years, and I was asking you to solve for the final amount. This time, I'm going to be giving you the final amount and asking you to solve for one of these three variables. There's going to be a lot of calculator work. There's different ways to approach some of these. I'm going to show you two different ways with the very first example, and I might go through a few different ways with each one of these as we go through. But I'm going to go ahead and lay out how I want these to be rounded throughout the assignment. So we're going to round dollars to the nearest cent. We're going to round our years to the nearest 100th. So that means two decimal places. And this one's a little bit tricky. We want to round rates to the nearest 100th of a percent. So what that means is we need to turn it into a percent first and then round it to two decimal places. So anytime we're looking for the APR, let's turn that into a percent first and then round it to two decimal places once we've turned it into a percent. So let's go ahead and get into it. I think it'll make a little bit more sense once we go. I have John invest $200 into an account that grows at 5% simple interest. Just like last time, as soon as I see simple interest, I'm going to write down the equation that I'm going to use. And I want to fill in what I have. So he invests $200. That's telling me how much he starts with. His rate was 0.05. Remember, we need to turn all of those into decimals. And then how many years would it take for John to have $350? So this time we know that he wants to end up with $350, and our variable here is years. So I'm going to show you two methods with this first one. I'm going to show you how to just think of this order operation style and distribute and then get the y by itself, which I think is how most people would want to do it. And then I'm going to show you how to just do it all in the calculator, which will be how I'm going to be doing this for most of my problems. But you can do it either way. But with the simple problems, it probably works best the first way I'm going to show it. With the more complex problems, it probably works best the way that I hold off to the very end to do the calculator steps. All right, but what I would do is I would distribute the 200. So that gives me 350 equals 200. 200 times 0.05, feel free to go to your calculator to do that, but that gives you 10y. And now my effort to get the 10y by itself, I would subtract 200 from each side. That gives me 150 equals 10y. And last step, and I'm going to squeeze this in here, I would divide by 10, and that would give me y is equal to 15, and that was going to be years. So that was a nice whole number. I would need, or John would need to invest $200 for 15 years if it's only growing at 5% simple interest just to have $350. So here's method number two. I'm going to erase method number one. Here's method number two to show you how I would kind of do this in the calculator all at once. And this is probably my preferred method, but I understand this may seem a little bit tricky for most of you to start with. And it does take a little time to get the hang of. So once again, I would write down the equation. I know that he wants to end up with 350. I know he starts at 200. I know my APR was 0.05 and I was looking for years. So I'm going to do the same steps that I just did. So I was just doing those like kind of one step at a time. I was doing a calculation for each step. With this method of getting y by itself, I'm going to hold off all my calculations to the very end. So if I get y by itself, I want to start furthest away, which is 200. That 200 is being multiplied. So I'm going to divide it to cancel it out. And then I'm not going to do any calculations in my calculator yet. I'm just going to leave that a fraction. And anytime I have a fraction, I'm going to put parentheses around it to kind of signify that it is a fraction. The parentheses over here are kind of going away because that 200 is not there to multiply it by anymore. And then I would want to subtract 1 from both sides. And once again, I'm not going to do any calculations. So I'm just going to leave that as 350 divided by 200 minus 1 is equal to, now on the right hand side, I just have 0.05y. And my last step is to get that y by itself by dividing by that 0.05. I need to divide the entire left-hand side by 0.05. So here's a trick. I need to put that entire side in parentheses when I punch it in my calculator. So this is going to be the answer that I punch in my calculator exactly how I punch it in my calculator. I do want to get in the habit, even though it's not needed here, of putting my numerator and denominator in parentheses. So I'm going to put parentheses around that 0.05. So this would just be open parentheses twice, 350 divided by 200. Close your parentheses. If you have the fraction tool, you don't have to have parentheses. You can just have it as a fraction. Minus 1, but you do need parentheses around your whole numerator. So make sure your whole numerator is enclosed in parentheses. And then divided by that 0.05. And press enter. And I should get 15. So I got the same exact thing that I got. I just held off on all my calculation until the very end. So this was 15 years both times. You can do whichever method you prefer. Like I said, I'm going to do most of mine with that second method, because when the problems get tougher, that second method is kind of helpful, because we're not dealing with ugly decimals throughout our problem. And we cannot round until the very end. Don't ever round between or like in the middle of your problem. You can only round at the very end. So I have Janet invests $1,500 for 48 months, which we know is 4 years. Go ahead and turn that into years. And account growing at a simple interest rate. So as soon as I see that, once again, I have A equals P, 1 plus APR times Y. All right. What was the rate of the account if she had $2,000 after investment concluded? So I know she ended up at $2,000. I know she started with $1,500. I know my rate is what I'm looking for, and you can call this APR. I'm going to sub this in as an X. And I know that it was for 4 years. I'm going to sub in 4 for my Y. All right. So I'm going to do this, the calculator method at the very end. So I'm going to first divide by 1,500. Even though that fraction can reduce nicely, I'm just going to leave it. I'm not going to try to do anything in my head, but I do know that that would reduce to 4/3. If you want to do that, you can. And then that's 1 plus, I am going to say x times 4 is just 4x. I just prefer to write it that way. So now to get the x by itself, I need to go start furthest away by subtracting that 1. So I have 2,000 divided by 1,500 minus 1 equals 4x. The last step I would do is divide by 4. And that gives me what x is equal. When I punch this in the calculator, and this is going to be what's missed a lot, when you punch this in the calculator, you need to have parentheses around your numerator, and even though it's unnecessary here, around my denominator. So I'm going to grab my calculator and try to move it to the other side so we can see what I need to type in. So this is going to be parentheses, 2,000 divided by 1,500. I'm going to close my parentheses. I'm going to subtract 1. I'm going to close my parentheses all the way around my numerator. So behind that 1, I had a closed parentheses, as you can see. And then I'm going to divide by 4. And this, since it's just a single number on bottom, I don't actually have to have parentheses. I just want to get in the habit of doing so. So I get 0.0833333, 0.08333. And then I would move the decimal 2 times, because this is a percentage, 8.33% when I round to the nearest 2 decimal places after I convert to a percent is what I get. Number 5, I have Rob wants to save $15,000 to buy a truck. He is going to invest his savings of $10,000 into account growing at 4% simple interest. So I know once again that I'm dealing with this equation. And I know he starts with $10,000. I know he wants to end up with a $15,000 truck. And I know the rate was 4%. So what I don't know is how long will it take Rob to save this money. So I'm looking for my Y. So once again, I'm going to divide by 10,000. And if you prefer the other method of distributing the 10,000 first and just doing this one step at a time, you can. Once again, 15,000 over 10,000 would reduce to 15 over 10, which would reduce to 3 over 2, which I would probably do if I wasn't just trying to stick to not doing any calculations until the very end. But if you feel comfortable with that, go for it. All right, so now I have 15,000 divided by 10,000 on the left-hand side. That's a fraction, so I went ahead and put it around parentheses. And then I have 1 plus 0.04 on the right-hand side, so I'm going to subtract 1 from both sides. That gives me 15,000 divided by 10,000 minus 1 equals 0.04y. I'm going to divide by 0.04, both sides. And I need to make sure that I put parentheses around my numerator and my denominator because that's how I want to type it in. And that's going to be what my y is equal to. Move the calculator to the other side again. All right, so I have parentheses, 15,000 divided by 10,000. Close your parentheses, minus 1. I'm just typing in exactly as I've written it over there, divided by 0.04. And this should be 12.5, so a nice even decimal, right? I guess so 12.5 years is, and I should probably write it like this, 12.5 years is my solution for this one. All right, I'll leave number 6 for you to do. Number 7, how much money should Jessica invest now into an account growing at 5.3% simple interest if she wants to have $10,500 in 4 years? So very similar setup. $10,500 is going to be my ending amount. I don't know my initial amount. I know the APR is 0.053. And I know she's going to invest for 4 years. So I fill in what I know. This time, I can see that all of this is in parentheses, and I'm trying to get the P by itself. So it's P times all of that. So I can just one step, if I'm going to do it in my calculator, just divide by all of that. So that's what I'm going to do. Got a little sloppy there, sorry. 1 plus 0.053 times 4. And that would cancel on this side, and it would leave me with my P is equal to. So now I just need to put this in my calculator. Once again, I'm just going to get in the habit of putting my numerator in parentheses, and you can see my denominator is already in parentheses, so I don't need to do anything extra there, but I'm going to type it in just like I see it. So I have 10,000. Sorry, it's right on my pause button, so I got to move it. 10,500 divided by, close your parentheses, divided by, and then that was 1 plus 0.053 times 4, and feel free to use the multiplication symbol there instead of the double parentheses, and equals, and that would be $8,663.37. $8,663.37 when I round it to the nearest cent. Sorry. All right. So Janet would need to invest $8,663.37 at 5.3% simple interest if she wants to have $10,500 in 4 years. Okay. So I'm not going to do many of these. It's actually should move a little bit quicker here. But the first examples, we're dealing with simple interest. We can apply the same technique to compound interest and compound continuously. So I'm going to move a little bit quicker. Just with this next set, we're going to be doing this equation, which is a more complex equation. And this is kind of why I say it's important to know how to type things in the calculator and not to round into the very end. So let's go ahead and start. So A equals, as soon as I realize that I have a compounded equation, as soon as I see that it's compounded quarterly, I want to go ahead and write the equation. So I'm just going to try to show you that I'm writing exactly as we see what we've already talked about, so I'm not going to go into the in-depth of the equation too much. So how much money would you need to invest into an account growing at 8% APR compounded quarterly? As soon as you see compounded quarterly, you write that equation in order to have $20,000 in 5 years. So I know what I want. I want to end up with $20,000. I don't know what to invest now, but I do know it's 8%, so 0.08 divided by quarterly would be 4, raised to the 4 times 5, and I did get in the habit of putting that in parentheses when we talked about this earlier. So now our goal is to get P by itself. Well, P is being multiplied by all of this. See if I can do this. I think a blue and a blue. Shoo. All right, it didn't make it too hard to see. All right, P is being multiplied by all of that. So what I'm going to do is just simply divide by all of that. 1 plus 0.08 divided by 4 raised to the 4/5, or 4 times 5, sorry, not 4/5. And that's going to cancel on the right-hand side, but on the left-hand side, I have 20,000 divided by 1 plus 0.08 divided by 4 raised to the 5 times 4. Okay, this is very important. We need to make sure that we're putting parentheses around the top and parentheses around the bottom, and then we can just type this all in our calculator. So that would give me my P by itself. So I have, if I clear all of this, 20,000. I'm going to close my parentheses even though that wasn't necessary there. I just want to get in the habit of doing it. So now on the bottom, I want to type it in just like I see it, which is hard to see. It's it's parentheses, and then another set of parentheses, and then it's 1 plus 0.08 divided by 4. I'm going to close my parentheses. I'm going to raise it to the, I don't have to have parentheses on my calculator, but your calculator might have to parentheses, so I'm going to put it there. 5 times 4. I'm going to drop down back to the ground. I do that by going to the right, and I press parentheses again. So I have typed it in just as I see it. Press enter, and I get $13,459.43. 13,459, 13,459, and I've already forgot, but I think it was 43. That would be your solution. So that seems complex, but it's really just typing in the calculator. I could have added one more set of parentheses here to note that that was a fraction also, but a fraction is just a division, so you don't have to have parentheses around it. But I would suggest in certain situations, you probably do need to make sure that you are putting your fractions around parentheses. And then the next thing I would suggest that you do is always look back at your answers and make sure they make sense. So this says that if I invested $13,459.43 at 8% compounded quarterly, in 5 years I would have 20,000. So make sure that logically you're not starting with less money than you're ending up with if it's something that you're investing into that's growing at a certain percentage. All right. Number 11 says find the APR of an investment of $5,000 compounded monthly that grew to $7,500. So once again, I have A equals P, 1 plus APR over N raised to the N times Y. That's my equation. I started with $5,000. I don't know what the APR is. I'm going to call that X just because I don't like doing APR. Monthly means 12, and this is 12 times the number of years. I'm going to have to add that, so I'll add it to your assignment too. Let's say in 8 years. So in 8 years, my number of years is 8. And I ended up with $7,500. Okay, so I was missing some information there, but I went ahead and added it, and I'll make sure I add it to your question that corresponds with this. But I have $7,500 is equal to 5,000 times 1 plus X over 12, all raised to the 12 times 8. So with this one, we are going to have to do piece by piece because there's no way that I can get this X outside of the parentheses without starting to do it like layer by layer. So I am going to first divide by 5,000. And you can type this in your calculator. That would be a simple fraction to reduce. I'm going to leave it exactly as is. 7,500 divided by 5,000 is equal to 1 plus X over 12. And I still need to keep all of that in parentheses. And I am going to do 12 times 8. I can do that in my head, which is 96. All right, so that's what I have on the right-hand side. All right, so now this is where it gets tricky. Since it's being raised to the 96 power, I have to take the 96 root of that, or another thing is I would raise this to the 196. So I want to raise both sides to the 196, so that should be new. But if I have the 96 power and I raise it to the 196, remember when we have a power raised to a power, we multiply. So 96 times 1 over 96 would just leave me with 1, which is what every exponent is understood to be if we don't have it there. So now I have 7,500 divided by 5,000 raised to the 196 is equal to, so now I can actually drop my parentheses on the right hand side because I've got rid of the exponent, 1 plus x over 12. I would subtract 1 from both sides, 7,500 over 5,000 raised to the 1 over 96, and I am going to suggest to put parentheses around your exponents even though my calculator doesn't have to have it, minus 1 equals x over 12. And the last thing I would do is I would multiply by 12, but if I'm multiplying by 12, I need to multiply the whole side by 12. So I'll write that a little bit nicer. I'll bring the 12 to the front. So it's 12 times 7,500 over 5,000 raised to the 196 minus 1, close your parentheses. That's going to give me what my x is equal to. So that was a complex one. If we would have turned it into, if I would have done my calculations early, that 75 over 5,000 raised to the 196 would give me a long decimal that I would have to carry down throughout the entire problem. That's why I prefer not to do so, but I have 12 times, parentheses, 7,500 divided by 5,000, close my parentheses, and I'm going to raise this. Now my calculator actually raises it in the air, so I don't need parentheses here, but I'm going to go ahead and do it. 1 divided by 96. I'm going to close my parentheses. I need to drop back down to the ground, so I press the button to the right, and it's minus 1. And then I need to close my parentheses. So I've typed it in exactly as I see it over here in blue, and I press enter, and I get 0.0507. And if I need to turn this into a percentage, because I'm looking for APR, that's going to be 5.079, which would be 5.08. So this would be 5.08%. And then once again, look back and make sure this makes sense. If I invested $5,000 at 5.08% compounded monthly, it may grow to $75,000 in 8 years. So that would be how it would do number 11. I'm going to add a year to your number 12, so don't look at that. Number 13, find the APR of an investment of $2,500 compounded monthly that grew to $4,324, and I need to add years to this. Let's say in 5 years. All right, so I have A equals P, 1 plus APR over N raised to the N times Y. And I know I started with 2,500, so that was going to be my original amount. And then I have 1 plus my APR is what I'm looking for, so I'm going to call that my X. I know it's compounded monthly, so I know my N was 12. I know this N was 12, and I added this part to my question, so 12 times 5. And that is equal to, I want it to grow to 4,324. So almost the exact same setup as the last one. First step I'm going to do is divide by this 2,500, get that parentheses by itself. I'm going to leave that 4,324 divided by 2,500. And I did it this way because if you try to turn that into a decimal, it's just going to be an ugly decimal throughout. But now I have 1 plus x over 12 raised to the 60. I do want to go ahead and do that calculation. It just makes things a little bit simpler. So now here's how to cancel out 60, just like we did last time. To cancel out that exponent of 60, I'm going to raise it again to the 1/60th. But if I do it to one side, I need to do it to the other side. That's going to cancel on that right-hand side. So I'm going to switch over to using black. So I have 4,324 over 2,500 raised to the 1 over 60 is equal to 1 plus x over 12. I'm still trying to get that x by itself, so I want to work furthest away. So I start by subtracting 1. So now I have 4,324 over 2,500 raised to the 1/60th minus 1 is equal to x over 12. And I would multiply by 12, but I need to multiply the whole side by 12. So that gives me 12, parentheses, 4,324 over 2,500 raised to the 1/60th minus 1, and I can close my parentheses, and that's what x is equal to. Promise you I'm almost done. Don't have too many more of these. Stick with me. So 12 parentheses 4,324 divided by 2,500. I'm going to close my parentheses, raise that to the 1/60th. I don't need parentheses, but I'm going to add them just in case your calculator doesn't need them. Just want to get in the habit. I need to drop back down to the ground, subtract 1, and close your parentheses. So you may see my mouse keep wanting to go to that negative. Make sure that you're not going to the -1 when you're trying to subtract 1. The calculator won't pick it up. But if I round this to the nearest 2 decimal places, I would move the percentage or move the decimal 2 times to turn it to a percent. So I get 11.01 when I round that second 0 up to a 1. So that's going to be 11.01%. Okay, 14 is for you to do. And now I got one more example, I think. Yep, one more example. And this one, it just shows you that we can apply the same techniques in the compounded continuous equation, which is a little bit easier equation to work with. So find the amount needed to invest in an account compounded continuously at an APR of 7% if you wish to have $10,000 in 5 years. So I know that I want to have $10,000 in 5 years. I don't know how much I'm going to invest, but I do know my APR, and I'm writing all over the equation. I do know my APR is 7%, and I do know my years is 5. All right, so what am I trying to solve for here? I'm trying to solve for P, and this is going to be a really easy one, so these are actually going to be easier. If you think of putting this whole part right here in parentheses, I can divide by e raised to the 0.07 times 5 on both sides. And that gives me my P by itself, and that's essentially all I was trying to do. So I'm going to type this in the calculator. I'm going to get in the habit of putting parentheses around the numerator and the denominator, and I'm going to type it in just like I see it again. See if I can squeeze it in over here maybe. Oops. So I know I'm covering it up, but it was parentheses 10,000. Close my parentheses, divided by parentheses E. And remember where E is, and it can be different on different calculators, but mine is right here in yellow, so to get to it, I have to hit second E. And it goes ahead and wants to raise it, but that was 0.07 times 5. I'm going to close my parentheses there that weren't needed. I need to drop back down, close your parentheses again, and then press enter. And I get $7,046.88. So $7,046.88 would be how much I needed to invest. All right, and then I just got one of those for you to do.